Hello, hi, welcome to our class for today. I hope you are all doing very good and fine. So this is No Mind Science Tutors Online, and for our class today we are going to be looking at position, distance and displacement. In our previous classes we have discussed everything that has to do with measurement in physics. So now we are going to position, distance and displacement. But before then, if you have not subscribed to this channel, please subscribe to this channel. We are here to teach you physics from your normal class setting. And our aim is to cover the full curriculum of physics for senior secondary school. So as I've always said, make sure you have your writing materials with you, your biro, your notebooks and your calculators, because as we progress this, we'll start to solve a lot of problems. So for this class, we are going to discuss position, distance, and displacement. Please, if you have not subscribed to this channel, please subscribe. Click on the notification button so that whenever we upload a new video, YouTube will notify you. Also, you can put your comment on the comment section down below. And at the end of this class, we are going to give you test your understanding. So put all your response, that is the answers to the test your understanding, on the comment section, or you can click on the WhatsApp link that is down below. There you can, the WhatsApp link will take you to our WhatsApp chat platform where you can place your answers and also put any other comment that you want to put there. You can place them in that WhatsApp platform. Then if you have any question to ask too, you can also ask your questions. We will review everything and give response to all your comments. Alright, so for this particular class, we're going to be looking at position, distance and displacement. So position, we're starting with position. So what is the position of an object, or how do you determine the position of an object in a plane? The position of an object in a plane is the point at which the object can be located with reference to a given point. The point at which an object can be located with reference to a given point. So assuming you have, let me just draw this. Assuming you have a plane like this and there's an object here. So, and this is your reference point O. The point at which you can locate this object, sorry, this line is not straight, with reference to this point is the position of this object. And you take your measurement from the vertical line. So that is how you can locate the position of an object with a reference point O. Okay, so I have a drawing here that explains it better. Okay, so this is a Cartesian plane. This is a plane. This is a plane. So assuming you want to locate the position of this tree, if you want to locate the position of this tree, what you do is that this is the reference point O and this is your tree. Then you have your X and your Y. You have your X and your Y coordinates, right? Then this is a plane Cartesian. So if you want to locate the position of this tree, you draw perpendicular lines from this point to this on the y-axis, then from this point to this point on the x-axis. Where these two lines intersect will give you the position of the tree. So assuming the line on the y-axis is 5, the point on the y-axis is 5, and the point on the x-axis is 4, you can actually write the coordinate points of the tree as 4 and 5. The 4 represent the X, the 5 represent the Y. The X is written first before the Y. You should know that one from your mathematics when you are drawing your graphs. So this is how to locate a point on the plane. Alright, so this is exactly what I've discussed already. You start by 1. Measuring the angle of view of the tree with reference to the vertical line through O. So this is the vertical line through O. So you measure the angle. You can measure the angle from this point to this point using your protractor. Then also you can also measure the position of this point by noting the point of intersection of the perpendicular line drawn from the marked points on the X and Y axis. So this is the perpendicular line that is drawn, and these are the perpendicular lines. Then this is the point of intersection. So basically that is how you can locate the position of an object. You can also locate the position of an object through the bearing. Yes, you can locate the position of an object through the bearing of the object. So the bearing is the angular direction of a point on a plane with reference to the true north, or with reference to two cardinal points, east or west, north or south. So there are two types of bearing, right? There are two types of bearing. You can write it in a compass form. So you have compass bearing and three-figure bearing. You can represent your bearing either with the compass point, that is using the cardinal point, or you can represent it with 3 figures. So this is an example of a compass bearing. So when you see a bearing that's written with the cardinal points on it, that one is a compass bearing. Then if it is written without the cardinal points, it is a 3-figure bearing. When you study your bearing, your mathematics, you will see this one better, right? So assuming the tree we are talking about is located here, and then this is your true north, this is your south, your west and your east, and the angle between the true north and the tree is 30 degrees. You can state the bearing of this tree as either a compass bearing or a 3-figure bearing. So the compass bearing of this tree from this north is north 30 degrees east, because the tree is towards the east. So this is north 30 degrees east. That's the position of this tree. Or you can write it as 30 degrees, 030. This is 3-figure bearing, 300, because you measure your bearing from the north. So if you put your protractor here, you can use it to measure the bearing, or use it to measure this angle from the true north. So you can locate the position of a point using the plane Cartesian or a bearing. Okay, so we are looking at distance now. We've talked about position and how you can locate the position of a point on a plane. So what about distance? Distance is the separation between 2 points, right? It's a measure of the separation between 2 points, say maybe A and B. So when you have 2 points that are apart, the space between them is the distance. So when you measure that space between 2 points A and B, what you have will give you the distance between the 2 points. So like if you measure the space between your classroom and your laboratory, the space between your classroom and your lab in school, that is the distance. Or the space between your desk and your board is a distance if you measure it. is a distance. So distance is a scalar quantity because it has magnitude but no direction. So distance does not have direction, it is a scalar quantity. And you can use any of these instruments to measure distance. Your meter rule, you can use a vernier caliper, you can also use a micrometer screw gauge. Then the unit of distance is the meters. Unit of distance is the meter. You can also use a tape. You can use a tape to measure distance. So if you have 2 points A and B separated by a space, the distance between the 2 points can actually be calculated. So assuming a ball circles from A to B at a speed of 5 meters per second, and it took the ball the time 10 seconds. To calculate the distance between A and B, or to calculate the distance covered by the ball, you can get it from this formula. Average speed is equal to total distance traveled all over time taken. So for you to calculate the distance, you now make distance the subject of this formula. And if you make distance the subject of the formula, this is what you have. Distance equals to average speed times time. Average speed times time. So for in this case, the distance covered by the ball will be, you will be given your speed. Your speed is given to you to be 5 meters per second, and time is 10 seconds. So in physics, you must always state what is given to you. Then you bring it to this formula. That distance is equals to speed times time. So substitute these values there. 5 times 10. So and that gives you 50 meters. So that is the distance that will be covered by this ball that cycles from A to B. This is the distance that we covered using this formula. Is that okay? So I want to do another example. See, to drive one point. Okay, this is actually a JAM question from one of those years. It says that an aircraft jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? It's a JAM question. So in this particular question, you are given speed to be equals to 335 meters per second, and then the time for the journey is 5 seconds. So just substitute that into that equation. You have that distance covered will be equals to speed times time. So that gives you 335 times 5. Now when you multiply that, we're going to have 1675 meters as the distance covered. So this is the distance that the aircraft will cover when the gun is fired. Yes, the aircraft will have covered this distance, 1675 meters, when the gun is fired. So basically, that is how you can solve for distance using this equation. Distance between 2 points A and B on the Cartesian plane. So sometimes you can be given 2 points on a plane, and then you are asked to find the distance between the 2 points. So assuming the 2 points, they are represented by 2 ordered pair of values, that is S1, Y1, and S2 and Y2. You can use the simple equation. You can use the simple equation to find the distance between the 2 points. Now, if you look at this equation very well, this is equation is derived from your normal Pythagoras theorem, because look at the triangle that comes out of the representation of the 2 points on a plane. So this is S1, Y1, and this is S2, Y2. The difference between Y1 and Y2 gives you this distance. So if I represent that by C, so the difference between Y1 and Y2 is BC, and the difference between S2 and S1 is AC. So you know that this now gives you a right angle triangle. This gives you a right angle triangle. So for you to find the hypotenuse side, it means you are going to find the square root of the sum of the squares of the other two sides. The square root of the sum of the squares of the other two sides. So with that gives you this particular equation, the sum of the squares. When you have this square and this square, you sum them, then find their square root. That gives you the distance between A and B. So we are going to take an example there to drive home that point that we just discussed. So this is a question. It says determine the distance between 2 points A and B on a plane. Now the 2 points are represented by these two other pairs, 5 and 3 and 9 and 6, and this is what I've represented on this diagram. Okay, so this is point A. A is between these 2 points, and then B is between these 2 points. Alright, so if you apply this equation, you are going to have that distance AB will be equal to the square root of this 9 minus 5 squared plus 6 minus 3 all squared. So when you do that, you're going to have 4 squared. 9 minus 5 is 4. 4 squared plus 3 squared plus 3 squared. So that gives you 16 plus 9 square root. Square root of 16 plus 9. 16 plus 9 is 25. 16 plus 9 is 25. Wow. So the square root of 25 is equal to 5. So that gives you 5 units. So for this one, your answer will be 5 units. So that is the distance between the point A and B using this formula. So that is how to find the distance between 2 points on a plane when they are given by ordered pairs of values. When they are represented by ordered pairs of values, that is how to find the distance between 2 points. Okay, so this is your test page. Please review what we have taught, what we have learned, and then use the examples that we have solved to solve these problems, right? Solve the problems, put your answers on the comment section. I will review and then check all your comments. Then also you can click on the WhatsApp link. It will take you to our WhatsApp chat platform where you can also put your answers, then put your comments there too. We'll look at all your comments and all your suggestions. So thank you very much. This is where we are ending our class for today. If you have not subscribed, subscribe to this channel, and when we upload any video, YouTube will notify you. If you like what we are doing, give us a thumbs up, and then also click on the notification button. You can also invite your friends to come and enjoy this physics class out of your normal brick and wall classroom. So thank you very much. We will see you in our next class.